And okay, so please go ahead.
So I will start. First of all, welcome everybody to this presentation in which me, Vito from BMW, and Roberto here from Intel are going to give some hints on how actually to fit open source software to the current version of the ISO 26262. So let's begin. Gabriele, you can switch the slides. So the first question we should ask ourselves here is, why should we use component off the shelf? It is quite clear that in these years, the automotive development cycles are becoming faster and faster. So this is, of course, there's a big impact of the software, of course. Hence, the interest towards this component of the shelf, open source in particular, is increasing. These components, open source, have actually sometimes an high quality, and they are state of the art. So we have some prominent examples. The first one will be the Linux kernel, which is basically the topic of this project. But we have also other examples like the C++ standard library coming from the LLVM projects, which is also a quite prominent and good examples to think about. Of course, by using open source components off the shelf, we basically do not want to reinvent the wheel in this case. So let's jump into the core of the presentation. I will now hand over to Roberto, and I will take over again later. So Roberto, please, you can continue.
Okay, thanks, Vito. So basically, before starting to browse to read ISO standard book, if you are appointed as a functional safety manager, the first action that you need to perform is to check your intended software functionalities. So basically, it means to analyze the context of your component and then the intended usage by using a software integrator perspective. Then, according to this point of view, basically you could have two different kind of scenario. So you could have a software functionality with no allocated safety requirements. Basically, it means to according by looking at the standard, there are no additional consideration requested by the ISO 26262. But the only exception is represented by the coexistence of the elements. Then what you need is to contribute on the analysis in order to ensure the dependent that the freedom from interference. Then there are no dependency between your elements and the other ones intended to be used for functional safety purpose. The second scenario is software functionalities in which you have allocated safety requirements. Then it means basically that your intended functionalities are safety relevant. Basically, you could have the case in which you have your safety function is used, for example, for to enable the safe execution of a nominal function, or for example is used to achieve or to maintain a certain safe state or a degree state. And basically in that case, the software integrator could add in its system, if required, obviously, according to the specific analysis, could decide to add a safety mechanism. Then, by using a component perspective, the safety mechanism is external and is used in order to enforce the robustness of the overall final system. The second scenario here, sub-scenario, let me say, for software functionality with allocated safety requirements, basically the component, in that case, the software functionality could be used for detecting, for monitoring, basically the presence of, for example, faults, hardware and no faults, coming from the hardware platform intended to be used, in which the software is used. Then, according to the different kind of functionalities, then as a functional safety manager, you need to apply an appropriate tailoring of the ISO standard. Then the real question here is, okay, but according to that safety standard, which kind of methods I can use for in order to be in compliance with the expectation for functional safety. Then here we have a sort of a summary in which in one column we have the list of possible safety relevant software component, and then you could have a component, basically a new developed design. You could have an existing design with no change, or an existing design in which you want to include to modify something in, for example, in the code. Then the ISO standard offers basically four types of methods: in contest, primary in use argument, software SEOC, and the qualification of software component. Now, in contest basically means to apply the part 6 of the standard, focus on the software development process. The primary in use is connected with the part 8, clause 14, if I remember correctly. The software SEOC, the information about the SEOC are captured in the part 10. Is included in it has been included in the second edition of the standard. And then last but not least, we have the qualification of software component. Now let's check quickly these methods, and let's try to understand basically the main differences. Okay, in context basically it's trivial. So we have basically we have followed the discussion about the adaptive AutoSAR platform, but basically the case of in context development means that we have clearly a vehicle, then a customer responsible to define a concept, a functional safety concept. Then, according to that item, this functional safety concept is created by using a hazard risk analysis usually. And then from the functional safety concept, basically we derived a list of technical safety concepts allocated to the system to be implemented in the vehicle. Then, by using this list of technical safety requirements, we allocate software, hardware requirements, hardware software interface specification, and basically we build our architecture. Then, according to this allocation, our responsibility as a component provider is to define the spec associated to our specific component, then to create the design, then the code. And obviously, according to the classic V model, there are different level of test, integration test. There are the unit test, the integration test, the acceptance test, and the final validation. The validation means basically the final, to validate the design against the concept. Obviously, that the advantage of this approach is we have no mismatch with the customer items, because we have a unique items, we have a unique customer, and then our goal is to satisfy the expectation of that customer. Then the effort is to reduce strongly the possible iteration and discussion with our customer. Obviously, the cons connected with this method is very difficult to reuse. So once conceive a component and I wanted to reuse that component in a different scenario, it's very complicated to extract the same component, then to reapply, to reuse the same one in a different context. Then, in conclusion, basically we can say is autoscope for a course. Now, second method, the primary news. Basically, the primary news is the scenario in which, for example, we have a library, existing library, and since this library has been already created, then is an existing software, it's possible to collect on-field data from our car maker in order to have the appropriate list of argumentations to justify that this design is usable for the car at the end of the story. Now, the real problem that we have on applying this method is in the ISO standard, frankly speaking, the part 8, there's no a clear guidance about how to apply the methods. And then it open basically the possibility for the system providers to apply the proven use concept in a different manner. And this is one point. The second point is obviously that we need the field data. So it's very complicated to, if you are, for example, responsible to write a firmware or a piece of software, hardware dependent software, it's obviously that it could be very difficult to receive this information from the car maker. Second point. The third point, and this is another concept, is once received that data, how we can ensure that these information are usable for justifying the usability of the design in one context, in a specific context of our customer. And then obviously that we need to use, once received the data, to define an appropriate method in order to elaborate the data and then to create that justification. The last point is related to, obviously, that conceptually is not applicable, this method, if we change the type of product or we are using a different technologies. Then what we can say as a cons is this method is not applicable if we wanted to create a scalable design. Okay. Third method, related to the now we are referring to the safety element of the contest, then SEOC. Okay, the SEOC is a very nice method added in the second edition of the ISO standard. Basically, conceptually, in a few words, it means to remove the concept of the item by using a list of assumptions. Okay, assumptions that describe the use cases, assumptions that describe basically the intended usage of our system. And this method has been created because basically you could have, as a perspective of a component provider, basically you don't want to create a component only for one customer, but basically you want to satisfy multiple car makers, multiple customers. And then by creating a list of assumptions, it's possible to match different use cases scenario. Then usually the technical safety concept is created by the component provider. And then the technical safety concept includes that assumption in order to match more than one use cases. So conceptually, the advantage is that the design, the component is perfect to be reused. And basically the interface between the partners is well defined and minimized. Now the risk that you have on applying a SEOC concept is obviously that since you are trying to satisfy multiple customers, multiple car makers, the risk is to have some mismatch. And then when you have that mismatch, could be complicated to try to modify one assumption if the design has been already created according to that. It's difficult, obviously, could be difficult to integrate a SEOC in the context of the overall system, let me say. And then you need to apply to define an appropriate method for integrating your component in the overall context. And last but not least, in that case, once identified the list of assumptions, the SEOC must be in compliance with the ISO standard. Then it means that once cut the component, the development, design, and testing must follow the ISO standard series. Now, according to what I said, basically the SEOC as a method is out of scope for a COGS, if not originally developed as a SEOC. So it means that if I want to reuse an existing software, okay, we can do that, but only if it's already conceived as a SEOC. Otherwise, this method is not applicable. About the qualification, the question? Okay, so about the qualification of software components, the last method, okay, is very simple. Here it means basically to have a component that you are considered as a sort of a black box. Then It's very simple because you consider only the list of the requirements, okay, that you want to allocate to that black box, and then you want to verify by using appropriate list of tests, you want to verify that the requirements are satisfied. Obviously, that the issue is, the concept here is, if you increase the complexity of the software design that you want to qualify, it's very complicated to collect the entire, to map in a proper way the list of requirements and the test associated. And then the effort is a limited scope for a course. Now, here I would like to open a note. There are sometimes some confusion about the SEOC and qualified component. Okay, since as I described now, it's very complicated to apply the qualification of software component for a complex software design, the approach is basically to apply a sort of reverse engineering. So reverse engineering means to go in the details of this black box and then to verify that even if it's created this black box by using a different standard or an internal process not in compliance, not by looking the requirements of the ISO, basically by using a reverse engineering, the idea is to assess the black box and to justify that the black box is able to is in compliance with the safety standard expectation. Then when you apply the reverse engineering, basically you are backing on the SEOC. So basically what you're saying, what we are doing is to consider this black box, to assess the black box, to justify that the blocks is developed and tested by using ISO requirements. Then you classify your design as a SEOC, and then it's reusable. Okay, then when a certain company proposes to apply a reverse engineering, conceptually, in a practically way, is adopting a SEOC in order to ensure the reusability of the design in multiple contexts. Okay, now the ISO offers these 4 methods. Concretely, if I'm a functional safety manager, which kind of card I can use? Okay, in theory, the current state of the art, the practical, practically speaking, the approach used for creating an overall safety system is that to have a system composed by hierarchical safety critical solution. As you can see on top, we have the item concept. Below, we have the system. The system could be a SEOC, or some elements of the system could be created by using a SEOC. And then another level for building the components. In that case, each components used for creating the system could be developed in context, could be developed again as a SEOC, or could be qualified by looking at the SEOC. So as you can see, an overall system could be a combination of methods, and then a combination of components that are qualified, that are in compliance with the ISO standard by using one of that methods. So we cannot have only one system, one solution in compliance, for example, entirely with the part 6. Okay, it's up to you, depending on what the intended software functionalities that we have described at the beginning of this talk. Okay, now I would like to give the...
I'm over again.
Yeah.
Exactly. So let's take a step back to ISO 26262 Part 812, qualification of software component. We already said that by applying this to complex component of the shells, in particular also to open source, it is quite clear that this part is not giving us enough guidance. So let's take a look to some shortcomings that might get addressed in future development of the ISO. This is a kind of wish list we elaborated after gaining some experience with this part. So of course, it is quite clear that only compliance with the formal software process, which is defined by international standards, there is addressed. This is actually an input needed to the software components. This means that if an open source component is not following, for example, ASPICE, this clause is actually not applicable. So what we would like to have in future is the possibility to extend this part also to software which do not only comply with the international standard, but sometimes, like Linux, might define their own development process. Second part here is actually that the code design diversity of the component is not addressed at all. So we only talk about software components there. So there is no thresholds given by complexity or type. And this is, of course, one of the main issues we have here. So another point in this case will be that actually there is no guidance to how to execute the safety analysis on the software code design of the architecture we will have in a complex software components. Another point, which is quite important there, is that there is no notion of mixed criticality. So again, as soon as the component is simple, this is okay. But in the moment we go out to complex components, for example, Linux, the notion of freedom from interference and software criticality is central, and this must be present in the qualification approach. Last but not least, we have actually, that's not last, that the verification strategy defined there is quite simple. So you just get that you have to write requirements and test them. Of course, again, for simple components, easy. But in the moment you have a complex component with deep hierarchical structure, with a complex architecture, you need to have a stronger verification strategy with layers, like, for example, similar to the V model, even not following the pure V model, but anyway, something must be there. Now, last but not least, we already said that the development cycle are becoming faster. This means that once the software is out, you need to push to patch this software sometimes because of other stakeholders, for example, security. So let's think of Linux. Let's think of the security patches. Right now, if you open up part A12, you will always only find that the software must be used without changes. And of course, in the moment we have changes, this is not applicable anymore, and we need to think how to overcome this point. Well, this slide here is a kind of wish list we would like to see to get addressed in the next ISO version, because in the reality, what it happens that as you do not have this guidance, you are forced to think out of the box, and sometimes, of course, yes, the whole assessment of such strategies becomes harder. So let's take again a step back, and if you can jump to the next slide, we will see basically what happens when you are writing down a qualification plan or an FMEA, in this case for the software components. So you will basically start listing failure modes and how they are covered by the integrators. Well, this is quite clear that in the moment you have a complex software component, let's take the operating system, this kind of list becomes unmanageable. So you will have probably thousands of failure modes, and of course maintaining this list is harder. So this is again a clear example of how you should think differently. Probably you have to introduce a deeper granularity of to solve this problem, and not just see this as a monolithic block, as a only component, but of course to increase your granularity. Well, this was actually everything from my side. So I will maybe you can jump over, Gabriele, to the next slide. Thank you for your time, and maybe there is time now for asking questions and answer them, Roberto.
Yes, we have 5 minutes for questions.
Mm-hmm. So seems there are no questions.
One question to Vito and Roberto. So you mentioned that the next edition of ISO, so how it looks like?
What we described there is a wish list. So this is something we would like to get addressed possibly in a future version of the ISO. Of course, we are not. This is not an official information, so please do not take them as a granted. We are just wishing something to the people writing the ISO
Yeah, so
here.
basically, yeah, let me add one comment. So obviously that what we need in the ISO standard, me as a project lead of the part 8 of the ISO, obviously that any hints received from this community, from ELISA, is very useful, because our goal is to update the 3rd edition in order to match basically the needs of the component provider, let me say. And in fact, for example, in the previous discussion about the AutoSAR adaptive platform, I'm very curious to understand if it's possible to extract other hints for updating the 3rd edition. Obviously, that here is just a collection of information. Then this is my rule here. I cannot promise nothing.
Absolutely. Yeah. And maybe we can link with maybe Christopher Temple or John in the line. Is there any hints or any solid timeline in ISO which are addressing these gaps in near future? Anyone from the line?
Okay, so basically here, conceptually, we are starting to discuss the topics. Then one of the topics is to have something to address better the qualification of software components, and is a topic accepted, recognized by the ISO community. Now there are different opinions, basically, because is a qualification of software component is just a sort of title, main subject. Now we are trying to discuss, we are discussing with the other ISO community members in order to identify the subtopics connected with this with that one. And then we are starting to this phase, this discussion phase.
Absolutely. That really makes sense. Yeah. Chris?
Yeah, I have a difficulty because there isn't really a gap, right? The safety element and a qualified component are different things for different purposes. That's why they have different names. And what this looks like is now the attempt by tweaking clauses of the standard to have the effort associated with a qualified component, but the luxury of being able to use it as a safety element. And this is kind of what I think is a little difficult. So either we would have to introduce something third, right? Because the qualified component has a very specific purpose and objective, and it's kind of not reflected by this here, right? But what I think everyone would like to have, including me, is the effort associated with a qualified component, but the safety, expressiveness, and capability of a safety element. But that is just it's a desire. It's like wishing for warm ice cream or whatever. It's very hard to achieve.
Mm-hmm.
No,
I
want to say that's a good comment. We also agree with that. I mean, this is why I was trying to give the term complex software component here to differentiate between the classical software component. Of course, this is a terminology problem, and it is your comment is right. That's something I think it's clear from my side. I don't know, Roberto, maybe you want to address something else.
No, exactly.
Maybe.
So basically here, the subject of this talk is just to introduce you the possibility for the audience, basically for ELISA community, to present the methods offered by the ISO standard, and basically to show the current state of the art. So it means how the community involved in functional safety use that methods. That hints are strictly connected with the part 8.12. So the qualification of a software component is applicable on a very simple design, simple libraries. Then our idea is, our hint is we would like to verify if it's possible to extend this qualification approach for something more complex. And this is basically a goal. Now, could be usable for Linux. Maybe, I hope. This is the the intent of the good intention of our discussion here in ELISA. But what I'm presenting here, what we are presenting with Vito, is the action from by using the ISO community perspective.
The point here is also that you have actually a clause here in the ISO, which is actually probably not clear, and which is applicable only to simple component. And what might happen in the reality is that somebody might come up with the idea to use that beforehand on complex software components again. And this guy might find an assessor that assesses this qualification as correct. And of course, the results won't be so good as we expect. And the idea here exactly to give guidance and support this qualification of software components, and avoiding that strange argumentation comes up because of the standard is not clear enough.
Okay, so we are over time. However, we have like some questions from the chat. Maybe I mean, we should have a break, but if you want to take these questions first, and then we can have 10 minutes break.
For me, I'm fine to answer the question if you want.
Okay, so there is first question is, do you know when the next version will be available? The next version of the ISO 26262.
I think is planned for 2023, but I'm not sure because it's something that is ongoing. At the moment, for the community, at the moment we have established a list of topics, interest topic for the third edition. And then we are starting the discussion, a deep discussion of that topic. And then obviously that it depends on basically the timeline followed for each topic. So I've not an answer today.
Okay, so next question from Shua. What are the challenges as you see them on using ISO 26262 that doesn't address code design and diversity to ELISA?
Well, I think that one of the approaches, and I think this is the target of the next talk, is to present, obviously that here, if we are thinking to use only one method for our Linux kernel, no, frankly speaking, is not possible. There's no way. But in reality, is the same issue that other companies has. And then by using a combination, a combination of methods, and then maybe one component could be qualified, another component could be defined using a SIOC in context, etc. That mix of solution create a final product in compliance with the ISO standard. Then what we need, I think, for Linux is to combine in a proper way the methods offered by the ISO standard. And if we use that approach, basically we can claim that we are in compliance with the safety standard series without any issue.
Okay. Next question is, how security aspects will be taken care with open source design along with safety?
I think that, so to say, the most relevant part of the security is that the fact that you need to update your software frequently, while for the safety, it was not considered a tool up to now to update the software. This is the first conflict point we have. And this is actually solved in the moment you will have a valid, qualification strategy which scales with the updates. Of course, there are points also in common regarding the technical aspects, but of course, I don't have it in mind at this moment. So the maintenance strategy is for me the first contact point. Please.
So Vito, you said update, but when we update the baseline, do we need a recertification of the delta, of the safety?
Yeah, that would be the idea, that you might evaluate the delta you are updating and the impact of this delta on the qualification without, of course, re-executing your qualification. So that's what we would like to see. This is right now not considered at all.
Unfortunately, when basically what you're describing is to apply a change on your existing software, and then basically what you need is to apply an impact analysis of that changes and to verify that you have not touched the intended software functionalities for functional safety purpose.
Okay, then we have next question from Shua. I think this is similar to the previous one, or somehow, I think Roberto, maybe you already answered. So all of the announcements you are suggesting are what you are looking to address in ELISA. How do we apply this standard on ELISA?
Okay, so the question is related to the methods. Then how to apply the methods for ELISA.
I don't know, Shua?
I'm sorry. What's the question? Are you asking the question? Clarification here?
Yeah, clarification about the last question. Yes, if it's possible.
So yeah, I was looking to see on this most of the feature developments you're suggesting on the ISO 26262 are some of the things that we are trying to address. Like, for example, if you take a look at mixed criticality systems. And so how do we, you answered the question earlier that you take, if I understood correctly, you take Linux, which is a complex system, and you break it apart and analyze each piece parts, correct?
Exactly, it's correct.
So my question is a little bit follow on in the sense that all of these are the ones we are trying to address in ELISA on a complex system like Linux. And then even how do we ensure, even if once we can break the system into multiple parts, yes, we are simplifying them and we are analyzing them into independent individual parts, but at the end of the day, all of this works together. So how do we ensure the analysis that we do on each of the individual parts would apply to the total?
It is a good point, but basically what you are describing is something like that, in which you have something that you qualify, for example, then patch that you wanted to qualify. You could have patch focus only for FUSA purpose, for a certain specific functionalities for functional safety. And you could have other possibility to use the SIOC. As I described before, if you apply reverse engineering and then you want to analyze a certain piece of code and to apply reverse engineering in order to show the compliance with the process used with the ISO standard, basically what you are creating is a SIOC block. Then the final, when you combine these elements, you have something above at the integration level that you must analyze again by using one of that methods. Could be a SIOC, could be in contest, could be in proving news, could be a SIOC as well. So according to this hierarchical level, it's possible to split the design in multiple components and then to select the appropriate method for the component that you're focusing. Then when you want to integrate that components in a Unix system, the integration phase, okay, should be assessed, let me say, or should be designed by using again one of the methods offered by the ISO standard. This is a sort of a hybrid approach, let me say.
Okay.
And this is the reason why you trust that you are in compliance with the functional safety, because each level are mapped, each component, each level are mapped with appropriate methods as described in the ISO standard.
So, okay, thanks, Roberto. I think now we need to stop the session because we are 10 minutes over time, and in 5 minutes we have another one. So
thanks anyway. Thanks
thank
a
you.
lot for the great question.
Thanks, everyone.
Yeah, if you have more feedbacks or question, you can also follow up offline by emailing, of course, right?
Thank you.
Okay, thank you. Bye.
Bye.
Okay, thank you very much.